started. Welcome to Dehydrated FHIR. We have our speaker here with us today. We will be doing a pre-recorded presentation, but he will be available afterwards for questions. If we do end up losing him due to connectivity issues, everyone is welcome to post their questions in Q&A, and he will answer them afterwards. And now I'm pleased to welcome our speaker.
Hi, welcome to my talk. I'm Greg McKay, Engineering Manager in the Health Graph Modeling team at Babylon. Today, I'll be talking about Dehydrated FHIR, and in fact, about Hydrant, which is a FHIR-specific templating engine. Historically, at Babylon, we had a problem with data silos. Different teams had different data in different places, all in different formats. Here, we see three separate services, each with their own databases. And in reality, we have many more. And we also have external partner integrations and services with data that also is in another service. And basically, this made it absolutely impossible to search across all of the data. And the solution, of course, is to unify the data and have it all available in one place. If you saw Alex Morley's talk yesterday, he spoke in detail about how we fix this by putting our data into a single opensearch store in FHIR format. But actually, just converting the data into FHIR brought challenges. To see why, let's take a look at some of the data from the domain service for body measurements. Now, this is a very simple service that just takes in different body measurements through an API and stores them. The data is simple, it's easy to understand, and it's low overhead for service developers. Now, because it's such a simple service and it doesn't have to deal with interoperability, it can get away with that. And if you're calling this service, you know you're getting a body measurement back, so you already have a lot of context around what these numbers mean. If we look now at the FHIR data, it's much more complex, but for good reason. It has all of these other fields that we need to make it understandable in a wider context. For example, category, code, status, etc. And basically, we need these when we come to have our central store to make sense of the data when it's mixed with lots of other types. But that introduces a lot of overhead, and especially for those who are unfamiliar with FHIR. If you put yourself in the shoes now of one of the developers who own the body measurement service, you're being asked to take your nice, simple data on the left and add all of this extra stuff you don't care about, and then send it on. You have to write more code, you have to introduce a new complex domain model all into your code. And, it's really easy to get something wrong because, this FHIR thing is so general and huge, and there's just so much to absorb before you know that you're doing it correctly. Now, we tried this. We asked the developers to add all of this code to, and add FHIR into their code base, essentially, and they hated it. They hated us for asking them to do it. And now if you multiply that problem by 10, 15 different services, possibly more, most of them were a lot more complicated than this one too. And now you can see why we needed a better solution. So let's look at what we're fundamentally asking these developers to do. We take some fields on the left and then drop them somewhere within the larger structure on the right, sometimes with just a little bit of transformation. And notice that most of the FHIR resource on the right won't actually change within the context of this service. So all of the data on the right that's in the white, category, status, etc., all is just static when it comes to body measurements. And instead of writing code, what we can do is actually ask our developers to create templates to define where inputs appear in the output FHIR. So we ask them to do exactly that. They create a template and they do that up front. So all the need to interact with the more complicated FHIR structure is done at modeling time. And that way it doesn't make its way into their code. And here, when they're doing this modeling, they can define all of the input parameters, their types, and whether they're repeated or optional, but also crucially where they actually map to in the FHIR resource. And this way, developers can still create their model, and in their code only, again, they only have to worry about the simpler or dehydrated model, as we like to call it. So that's the dehydrated FHIR or DFHIR, what you see on the left. And when it actually gets to the central store, we still get a fully hydrated FHIR. And now notice that you have two non-primitive types here in the definition of body measure. And in general, the types can be recursive. We can define the type to be an ID of another template. And that's useful, say, if we're filling in a list of repeated backbone elements, which can be quite complex, then we might need to reference another model. But here in this simple case, actually both of these types are enums. So here are these enums, so body measurement unit. That can either be centimeters, inches, or kilograms. And sometimes there's a more complicated case. Here you see the value for inches is a little bit more complicated, for the code for units of measure. It has some brackets in it, for example. And we just want to refer to it as inch in our DFHIR, so we give it a name alias, so you can do that. A little bit more complicated example for the height and weight. So let's say for height, we actually hydrate into the full codable concept representation, and we just give it the name of height. So that way, in the DFHIR, again, you just refer to height. In the value, you get this whole object of your codable concept. And yeah, and that means all of your choices for coding in this kind of situation can actually be done at modeling time as well, which is also quite useful. And if we had a repeated field, let's say we wanted multiple categories to be specified in the input, then we could define our our input DFHIR to be repeated, and the output templated value actually has to be nested within some list in the FHIR structure. So here, if we had an empty list of categories, actually the category list on the right would end up being empty. We wouldn't have a single object with no text field, if that makes sense. So it kind of propagates the repeated fields to where the actual lists are in the FHIR structure as well. Anyway, that's a brief overview of hydration. We map dehydrated FHIR to FHIR using a template. And we do this with a library called Hydrant. So Hydrant is a templating engine library written in Scala, so it's usable in the JVM. But that's not all Hydrant can do. So if you just look at the input parameters of a template, so the input parameters, their types and the cardinality, that allows us to generate protobuf schemas for sending our data on Kafka into our central opensearch backed FHIR store. So again, if you want to see more details on exactly the architecture of that whole setup, watch Alex Morley's talk if you didn't watch it yesterday. But anyway, yeah, so we also, from all of those proto schemas, we can actually generate code because Protobuf comes with a lot of code generation libraries for all sorts of languages. So that's really useful for us as well, because then we get code generation allowing people to produce DeFi very easily. Now, we know what the output looks like. For example, the resource type here is observation, and we know which fields are fixed. We know the types, cardinalities of the inputs, and that implies, of course, the types and cardinalities of the outputs. And using that information, we can actually generate FHIR profiles that let us know what our output FHIR is going to look like. And that's not all, because we also have enumerations, which let us build value sets. For example, we built height and weight value set. And if we were defining extensions in our output FHIR, we could also generate their definitions. And that wouldn't be possible with a more general non-FHIR specific templating engine such as Ginger, because they allow a lot more general transformations, and that makes the output a lot harder to predict and deconstruct in this way. We can also reverse the process, going from FHIR to dehydrated FHIR. And this lets us use templates to pattern match and extract data from FHIR. And again, this isn't possible with standard templating engines. Now, the DeFi is actually quite simple, so it's straightforward to create randomized DeFi data, which we can then hydrate. And then we can use that random data to actually test our templates. So we can actually build property tests to check the validity of the templates by generating DeFi, hydrating it into FHIR, then checking it against the generated profiles. Now this stops issues like getting the wrong types of fields, messing up references, things like that. We can also test random DeFi. So we generate random DeFi, hydrate it, then dehydrate it in order to check if we get the same result. And that catches a lot of issues like parameters that go nowhere, duplicate parameters, and etc. So that's Hydrant, which allows our services to use a simpler format. We still get the interoperability benefits of FHIR. We can build our FHIR mappings faster. We do more of that at the modeling stage up front, meaning far less overhead for code, far less overhead and code for application owners. And it also allows FHIR profiles, value sets, and extensions for free, because we just generate them. That allows us to know exactly what the data in our store, our central store, looks like. And then Protobuf Generation, allowing us to send the data around more easily, and code generation, making it easy for our software developers to actually send that data to us in the central store. And we also get these stricter contracts at the type level as a result of that code generation. So we are looking to open source Hydrant, particularly if there's a lot of interest. So if you're interested, please do reach out. Here's my email address. I'm really, really happy to hear from you. And we are also hiring. So we are a global organization, and our mission is to bring affordable and accessible healthcare to every human on Earth. I know there's a lot of people involved in FHIR who are interested in that. So please reach out, see our careers page at the bottom of the screen. And thank you so much for listening. Again, here's my email address. Please do reach out if you want to talk. Thanks so much.
Okay, it looks like we do have a couple of questions. Do we have any questions in the room?
Yes, we do. Let me just pass that mic around.
Let me see.
Hey, Greg. I was just trying to clarify when you said that format which is called the DFHIR, what is it? Is it still a JSON or is it not a JSON? Is it a YAML or what is it exactly?
So I guess we have multiple representations of it. So usually we send it around as protobuf, like internally. We basically use it for sending data around on Kafka. Again, I'm going to refer you to this talk that Alex did yesterday. But actually internally what happens is it turns the protobuf into JSON. So the way the library works is, yes, you can use JSON and convert the DeFi JSON into FHIR JSON as well.
So I guess what I'm trying to understand is this format used within a microservice, or when you're like, let's say you give an example, right, about the like the different silos. So within a silo itself, if you have different microservices talking to each other, that's when you will use this. But if it needs to traverse across, for example, your clinical system to your population health system, that's when you will actually run the Hydrant and it'll move it into the actual FHIR format? Or is it like the,
Yeah. So I guess, so long story short, I guess what happens is all of the services publish their events and they publish them as DFHIR. So the individual services publishing just need to worry about sending DFHIR. And then eventually when people come to read it and it's in the kind of bigger situation, where all the data is centrally, then they can read it in FHIR format or they can read the DFHIR directly. So and they kind of read it from one place, like a central store of all of it. Does that answer your question?
Yeah, I think I get the idea. I guess I'll just have one quick follow-up was what happens when you guys need like the template, like we used velocity before all this, so it was similar concept. So if let's say a new field needs to be added and needs to be now populated in that template, do you keep updating that template engine to add those new fields? Is that how you do it?
Yeah, so what we'll do is we'll add the new field to the template. And actually we have checks so that you can't add breaking fields to the protobuf schema. So the protobuf gets generated and it will check that you're only adding optional fields so that all the past data, is still fine. And actually it's quite nice because then if you add an optional field, for example, then that propagates to the FHIR template, the FHIR profile. And now that'll say, okay, this field is optional, because it's not there in the old data, but it could be there in the new data.
Okay, so you have some if-else logic built in within the Hydrate, whatever that Hydrate, I guess forgetting the name of that, right?
Hydrant, yeah. So yeah, exactly.
Yeah, Hydrant,
so we do keep templates up to date. Essentially, if we need to add new fields, we'll add new bits to the template.
All right, thank you.
So are there any other? Yeah, I see another question over here.
Thank you for your talk. One vote for open sourcing, or two, if I got him as well. We deal with a lot of HL7v2 as well as FHIR, and I was wondering if you has any thoughts about using the same Hydrant approach to HL7, that templating, reversible templating type of languages to that format instead of just the FHIR
Interesting. Yeah, I've not done too much with HL7v2 personally, but I don't see why not. I mean, certainly if you can convert it into, if it's basically a smaller data model, and a similar thing where there's within a certain context there's a lot of fixed fields, or I mean it just makes it easier to kind of extract fields, and then if there's relatively few of them, and put it into a kind of a larger FHIR context, especially if you've got to do a lot of that work. It just, our experience has kind of sped up that process a lot. So yeah, I mean, it's definitely an interesting idea.
Okay, I see we're about time, so I will please ask you to fill in your questions in the Q&A tab, and I will ask the speaker if you can monitor the Q&A and give your answers to the questions.
Of course, yeah.
Yes, it
So
looks like
then-
we have numerous in there right now.
Okay, will do. Right, thank you so much.
Thank you very much, Greg.